What you see here are extremely venomous animals, and what you're about to see in this report is that the same venom that can kill us could eventually help treat diabetes, cardiovascular diseases, allergies, or even obesity. What are you doing?
I'm extracting venom from this beaded lizard. It comes from Central America. It is venomous. Venom from a species close to this one has already been used to develop a treatment against diabetes.
This unusual farm in southern Belgium houses around 200 extremely venomous species. All these animals are carefully farmed with an ambitious research purpose in mind. Until now, these venoms were mostly studied to find antidotes, but that's apparently changing, isn't it?
Yes, we are currently using fundamental research to identify these venomous substances and find toxic properties we can turn into therapeutic potential. This venom comes from a dangerous viper from South America. It is a very active and powerful venom, a complex chemical cocktail, and we want to identify which of these components have a good potential to eventually develop new medicines.
Scientists from a European research project used mass spectrometry and other complex techniques to identify toxins from 203 venomous species. More than 4,000 of these mini-proteins were newly classified.
What we obtain on the computer screen is a graphic description of the molecular composition of each venom sample that we analyze. Different components are identified and classified according to their masses. Each peak relates to a toxin.
Once identified, these toxins were then produced through extremely complex biological and synthetic processes.
At the end of our process, we obtain a resin. You can see it here. The resin is later treated, so we get a synthetic product that is then going to be shaped to obtain the toxin that will finally be tested.
The obtained toxins were then indeed tested by screening them against selected molecular targets. Results were promising, researchers say. Venom-based drugs against some diseases are no longer a matter of science fiction.
We've chosen to focus on diseases like diabetes or obesity. In these two domains, we still need to develop new medicines.
So what now is the follow-up to your research?
Discovery and characterization processes take about 2 to 3 years. Then you need another 10 or 15 years to develop, test and certify new medicines prior to their eventual commercialization.
And as well as the health benefits, researchers hope their work will somehow lead to a change in our attitudes to fearful, yet eventually beneficial creatures.
Most of these animals are endangered. Their natural ecosystems are being destroyed. If we can show that these animals can also be useful to us, maybe we'll take better care of them, so they will eventually help improve our future health.